Okay, so today we're going to factor trinomials in this form. And I know right now you're probably like, what the heck is this form? And I'm going to show you in just a minute. But to start, let's just go over and let's simplify some polynomials just like we did with the difference of squares. So remember with difference of squares, these two terms in the front were the same and these two were in the back were the same, but the only difference was one was negative and one was positive. For this, it doesn't have to be the same term. In fact, if it was the same term with opposite signs, that would specifically be difference of squares. So on this case, let's see what they have in common here. So x times x is x squared. X times 5 is 5x. 1 times x is 1x. And then 1 times 5 is 5. So remember, we can combine the middle two terms here. And that's going to be 6x and then plus 5. Okay, let's do the next one. M squared plus 6m minus 4m minus 24. Remember, we can combine the middle two terms here, which is 2m minus 24. And then we're going to multiply k times k, so k squared. K times negative 3 is negative 3k minus 7k plus 21. Negative 7 times a negative 3 is a positive 21. We can combine the middle two terms, and that's a negative 10k plus 21. Okay, so trinomials like these can be factored back into a product of binomials. Remember, trinomials, 1, 2, 3 terms. 1, 2, 3 terms. 1, 2, 3 terms. These are called trinomials. And we could factor it back into a product, which means multiplication, of binomials. This is a binomial, 1, 2 terms. This is a binomial, 1, 2 terms. So we multiplied two binomials to get a trinomial. Okay, now notice what you see in front of the x squared, the m squared, and the k squared. What variable is in front of each of these? There's a 1, isn't there? In front of each of those. This method only works when there's a 1 in front of each of these terms, and it's a trinomial. Okay, so that's really important. So let's look at factoring trinomials. To factor a trinomial in the form, so you see how in this form, it doesn't matter what b is and it doesn't matter what c is, right? It doesn't matter. This would be like the b and this would be like the c. But what do you notice is in front of that squared term? It's a 1, isn't it? Just like here is a 1, just like here is a 1, just like here is a 1. So this is important to factor a trinomial in the form technically with like a 1 here you can think of. So 1x squared. Doesn't matter what these terms are. You must find two integers that multiply to a times c and add to b. I'm going to show you what this means in just a minute. Okay, so for example, notice how there's a 1 in front of this again. So we need to make sure for all of these examples we have a 1 in front of that x squared term, that squared term, whether it be x squared, k squared, m squared, but there's a 1 in front of it, okay? So we have to figure out what two integers have a product of 12 and a sum of 7. So we're always going to label a, b, and c, okay? So technically, this can be written as ax squared plus bx plus c. A is always going to be 1 in this case, only in this lesson. I'm going to introduce other numbers besides 1, but for now it's just going to be a 1. B is 7 and c is 12. So this is in standard form, the greatest variable to the least variable. Your a is the number in front of x squared, your b is the number in front of x, and your c is the constant, or the one that doesn't have a variable. So then we're going to draw an x. Okay, on the top of this x, we're going to write a times c, and on the bottom, we're going to write b. Now look what we just wrote. To factor a trinomial, you must find two integers or two numbers that multiply to a times c, so multiply to this number, and add to b, or add to the bottom number. Well, we just labeled a, b, and c, so what's a times c? 1 times 12 is 12. And what's our b term? 7. So we're going to put a 7 down there. Now, What two integers multiply to the top number and add to the 7, to the bottom number? So it needs to multiply to 12 and add to 7. So this is what we do. We think of the factors of 12, the factors of this top number. What multiplies to 12? 1 times 12, 2 times 6, 3 times 4. Do any of those numbers add to 7? Yes, 3 and 4. 3 times 4 is 12. 3 plus 4 is 7, right? So that's our answer here. So what two integers have a product or multiply to 12 and add to 7? 3 and 4. Write two binomials using these integers, then distribute to check. That's how we write the two binomials. How did I get that? Well, we have an x in our equation up here, right? X. I'm going to say x plus this number, 3, and x plus this number, 4. If one of them was a negative, we'd say x minus that number and x plus this number, or whatever it is. So we just put an x in front of whatever two terms we have here. That's our binomials. So let's distribute to check. X times x is x squared. X times 4 is 4x. 3 times x is 3x. And 3 times 4 is 12. Look at the middle two terms here. 4x plus 3x is 7x, isn't it? And that's supposed to be x squared here. So x squared plus 7x plus 12. Is that the same as the answer we got up here? Yeah, so that means we did this right. So your answer is x plus 3 times x plus 4. Okay, we're going to do plenty of examples. So here it says factor each trinomial. So again, we put a times c on the top, b on the bottom. Let's label a, b, and c. So a equals the number in front of the n squared, which is just 1. It's always going to be 1 in this lesson. B is 9 and c is 20. You see how we got a, b, and c here? A, b, c. Now we're going to multiply a times c. 1 times 20, which is 20. We're going to put it right there. B just goes on the bottom, whatever b is. B is 9. Now what multiplies to 20 and what adds to 9? What number multiplies to 20 and adds to 9? So all you have to do here is think of the factors of 20. What multiplies to 20 and adds to 9? 4 and 5. So 4 times 5 is 20. 4 plus 5 is 9. That's your answer. So now we just put an n instead of an x because it's just an n here. So n plus 4, n plus 5. That's your answer. Okay. Now the next one, number 2. Remember there's a 1 in front of that w. So 1w squared plus 9w plus 18. Let's label a, b, and c. A is 1, b is 9, c is 18. Draw the x. What multiplies a times c? What adds to b? So a times c, 1 times 18, that's an 18. And b is 9. So what multiplies to 18 and adds up to 9? 6 and 3. 6 times 3 is 18. 6 plus 3 is 9. Okay, so now look at what variable we started with, w. So it's going to be w plus 6 and w plus 3. That's your answer. Again, always check. If you want to multiply this out, which I would definitely recommend doing, to check to make sure you got that answer, then literally you do not have to look at the answer key or anything. You can just keep checking your work that way. That's an awesome thing to get used to. Okay, let's label A, B, and C. So A is 1, B is 10, C is 24. Draw the x. What's A times C and B? Well, A times C is 1 times 24, so that's 24. B is that middle number here, so B is 10. What multiplies to 24 and adds up to 10? So 4 and 6, and then we're going to write A, because we started with A plus 4, A plus 6. Okay, A again is 1, B is 2, C is 1. Let's draw the x. A times C goes on the top, B goes on the bottom. What multiplies? So A times C is 1 times 1, so that's a 1 up there. b is the middle term, b is 2. What multiplies to 1 and adds to 2? So a lot of people get confused here, but remember 1, to get to 1, you do 1 times 1, right? And 1 plus 1 is 2, so that's your answer. Now we look at our variable, we say y plus 1 and y plus 1. When they're the same, remember we could write it like this, y plus 1 squared. So if they're the same, you see how none of these have been the same numbers here, but if they're the same two numbers, y plus 1, y plus 1, we could write it as y plus 1 squared. Okay, let's label a is 1, b is 3, c is 18. Draw the x. You're going to put a times c on the top and b on the bottom. So a times c, 1 times negative 18. So that's negative 18 on the top. So now we're trying to get to a negative 18 and get to a positive 3. So we have to think of a couple different factors of 18. So first of all, 9 and negative 2. So let's just pretend we decided to choose 9 and negative 2, because 9 times negative 2 is negative 18, right? But if we subtract these two, do we get 3? No, 9 minus 2 is 7. So it's not 9 and negative 2. What about 3 and 6? Okay, so we say, okay, well 3, if we subtract these two numbers, like 6 minus 3, we get 3, but we need a negative 18 and a 3. Which one are we going to make negative? We're going to make that 3 negative because we want a positive 3 when we subtract. So 6 minus 3 is a positive 3. Negative 3 times 6 is a negative 18. So those are our two factors there. Now we look back here and we say, okay, we started with an n, so n minus 3 times n plus 6. And that's your answer. Okay, try 6 and 7. And we'll do 8. So a is 1, b is 4, c is negative 45. Draw the x. A times c goes on the top, b goes on the bottom. So a times c is 1 times negative 45, which is negative 45, and b is 4. So now think of all the factors of negative 45, and we know 9 times 5 is 45, right? But we need a negative. Which one are we going to make negative to make a positive 4? Well, 9 minus 5 is positive 4, and 9 times negative 5 is negative 45, so that's your answer. Now we just look back here, we say c plus 9, c minus 5. Oh, I put x by accident, sorry. It should be c. And if you did something like that on the test, I would not mark you wrong, okay? Because it's easy to think x. And that's it. That's your answer. Okay, let's try this one. They're all in different sets because there's different, it's because of where the signs are. You see how now everything is negative? And then you see how here how there's a negative and then a positive, negative, then a positive. And then at the very end, there's mixed review. So we can kind of practice everything together. So A is 1, B is negative 2, C is negative 3. But for all of them, we do the same steps. Notice we're still doing the same steps. So A times C is 1 times negative 3, so it's negative 3. And B is negative 2. Oh, I put the answer in too quick. Oh wait, no, that's not the answer. Okay, so we're trying to multiply to negative 3. And add to negative 2. Now, where do we put the sign? We know 1 times 3 are the only factors that multiply to 3, right? 1 times 3 is 3. We need a negative 3, though. Now, if we put a negative on the 1, 3 minus 1, is that a positive 2 or a negative 2? It's a positive 2, and we need a negative 2. So instead of putting the negative on the 1, we have to put it on the 3. 1 minus 3 is negative 2. And 1 times negative 3 is negative 3. So that's your answer. So now we look back at our variable. We say a plus 1 and a minus 3. That's your answer. Okay, let's label a, b, and c. A is 1, b is negative 7, c is negative 30. Draw the x. We're going to put a times c on the top and b on the bottom. A times c is negative 30 and b is negative 7. So now you have to think of what numbers multiply to negative 30. Okay, so we know 5 and 6, but that's not going to add up to negative 7, right? There's no way we could put negatives in any of these to make it add up to negative 7. But what about 3 and 10? So that, you could subtract those two numbers and get a 7, but we need a negative 7, so which one are we going to make negative? The bigger number, because 10 minus 3 would be positive 7. But 3 minus 10 is negative 7. We look back at our variable, x plus 3, x minus 10. That's your answer. Try 11. 12, again, I'm just labeling a, b, and c. I'm drawing the x. A times c is negative 64 and b is negative 12. So what number multiplies to negative 64 and adds to negative 12? This one you might have to use your calculator for. So just start dividing 64 to see how we can make a negative 12 when we combine these terms. Okay, and we're going to, if we did 16 minus 4, that's a positive 12. So we need to do 4 minus 16, which is a negative 12, and 4 times negative 16 is negative 64. So that's your answer. Okay, 13. So I'm going to kind of go quickly between A, B, and C because I think we've had enough practice with that. So I think you know how to get to this spot right here. But now we're going to find the factors of 24, of positive 24, to get to a negative 11. Well, 3 times 8 is 24, right? But we need a negative 11 and a positive 24. What do we have to do to both of these numbers to make a negative 11 and a positive 24? Well, we have to make them both negative. If there's a negative number down here and a positive number up here, you have to make both of them negative because a negative times a negative is a positive. But negative 3 minus 8 is negative 11. So that's it. X minus 3, x minus 8, and we're done. Again, we're labeling A, B, and C. We're drawing the x. We're putting the A times C up there and the B down there. So 49, we know 7 times 7 is 49. We need a negative 14, so we're going to make both of them negative. And then it's x minus 7, or remember, we can do x minus 7 squared when it's the same term twice. Okay, try 15 and 16. Oh my goodness. Okay, and then let's do some mixed practice here. So again, A, B, and C, label it. A times C is negative 16, B is 6. What numbers multiply to negative 16 and add to 6? 8 and 2, but which one are we going to make negative? The 2, because 8 minus 2 is 6, and 8 times negative 2 is negative 16. Now we write it out. A plus 8 and A minus 2, and that's your answer. 18, label A, B, and C. Put it in your X there. What multiplies to negative 72 and adds to negative 14? Well, 9 and 8 makes 72, but can we make that negative 14 anyway? No, because 9 minus 8 is 1, and 9 plus 8 is 17, so let's try another number. What about 4 and 18? So that we can do, and if we have to make the 18 the negative, because we have to have a negative number when we subtract these. 4 minus 18 is negative 14. 4 times negative 18 is negative 72. And then we just do x plus 4, x minus 18. Okay, I want you to try all three of those. I'm going to do 21. Again, write A, B, and C. So negative 30 goes up here. B is negative 1. What multiplies to negative 30 and adds to negative 1? Well, 6 times 5 is 30. And how are we going to make a negative 1? We have to make the negative the bigger number. All right, so we have n minus 6, n plus 5, and that's your answer. Okay, now look at the directions. Look for a GCF first, then factor. So, because remember, what number does this have to be? That has to be a 1 in this case. So we're going to get to notes where this doesn't have to be a 1, but in these notes we know this has to be a 1. So what's your GCF going to be? Your GCF is always going to be whatever this number is in this case, right? Because we need a 1k squared there. So we're going to take out a 4, and then we're going to label A, B, and C. So A, B, and C, ignore the 4. What's your A? 1, B, 3, C, 2. We do the same thing now. We have to multiply to 2 and add to 3. So 1 times 2 is 2, and 1 plus 2 is 3. So now we can say k plus 1, k plus 2, k plus 1, k plus 2. And the GCF has to go in front of it. That 4, you need to bring that down, and that's part of your answer, just like the last notes that we did. Okay, 24, we take out a 2. A 2 can divide into all of those. Okay, so 2x squared divided by 2 is x squared. Negative 8 divided by 2 is negative 4. Negative 24 divided by 2 is negative 12. And then we list a, b, and c, ignoring the 2 for now. So a is 1, b is negative 4, and c is negative 12. We do the same x. We have negative 12 at the top, negative 4 at the bottom. And we find that 2 and 6 work here, but we need to make the 6 a negative, and that's your answer. So x plus 2, x minus 6, bring the GCF down, and that's your answer. Okay, 25, take out a 3. So if we divide each of those by 3, that's what we're left with. We label a, b, and c. We draw the x. A times c is 4, b is negative 5. We know 1 and 4 are going to make 5, but we need to make both of them negative to make a negative 5. Negative 1 minus 4 is a negative 5, and when we multiply them both together, we get a positive 4. So now we say y minus 1 and y minus 4. We took a GCF out in the beginning here, so we have to bring that down, and that's your answer. Okay, and that's it. So try 26 and 27.